Hello everyone, I'm Dr. Prasad Puthiyillam. Continue my class series on Engineering Chemistry 21 CH3OH-O2 of Visvesvaraya Technological University. This is the class for Module 4, Green Chemistry and Alternate Energy Resources, class number 5 of that particular class video, in which I'm explaining about green fuel and solar energy. So in this particular class, I'm explaining about green fuel, that is mainly hydrogen production by photocatalytic water splitting, hydrogen production by photo-electrocatalytic water splitting, and the produced hydrogen, its application in hydrogen fuel cells, methanol oxygen fuel cell with sulfuric acid as electrolyte, its construction, working and applications. Then solar energy, introduction to solar energy, photovoltaic cell, construction, working and application. So all these classes are made available into my YouTube channel, My Intuition. Please do subscribe and support me. So before we discuss about hydrogen production by catalytic or photocatalytic, you already know the natural synthesis called a photosynthesis, that is for the production of food by plants. On their plant leaf, when sunlight falls, so it is a photosynthesis which is actually happening. We call it as a biological hydrogen production. The electron produced by the photosystem are taken up by the hydrogenase, resulting in the formation of hydrogen. And it is a bioreactor. It produces the biohydrogen, and this figure represents the photosynthesis. When sunlight falls on the leaf surface, water molecule combined with carbon dioxide produces oxygen, and the remaining hydrogen they are produced we combine with carbon convert into carbohydrates. So here you can see in between the hydrogen production is there, that leaves are converting into carbohydrate. It produces oxygen also. So the same concept can be used to same concept can be mimicked, copied artificially to produce a hydrogen. So the hydrogen produced in this process is used, the hydrogen produced in normal natural photosynthesis used for carbohydrate production. By using or copying that process, or by biomimetic, artificial photosynthesis can be done, and it is known as a photocatalytic water splitting as well as photoelectrocatalytic water splitting. So two concepts are there. First one, that is photocatalytic water splitting. In photocatalytic, the splitting of water to get hydrogen by using a photocatalyst and by using the solar energy, sunlight energy, is called photocatalytic water splitting. The process can be more efficient if the photocatalyst is directly suspended in water, so that the reaction takes place in one step. That means the photocatalyst is kept in water. So I am representing this as a photocatalyst. To a photocatalyst, when sunlight falls on the photocatalyst, is actually semiconductor also. It will excite, electrons will be excited. In same way, holes also will be generated. The electrons are generated, holes also produced. Now these holes, it can combine with the water molecule, to produce H plus ions as well as oxygen generation. Okay, so this is the formation of oxygen in a photo system. Now this hydrogen ion produced, it can react with the electrons, not in the photocatalyst itself. It need a co-catalyst, another catalyst supported to that near to that photocatalyst, or in combination with the photocatalyst. We call it as co-catalyst. Usually nanoparticles are used as a co-catalyst, in which the H plus ions are formed in the photocatalyst. It will combine with the electrons. The electrons will move near the co-catalyst. There it will be converted. H plus will combine with the E minus to form H, or 2H plus combines with the 2 electron, give hydrogen production. So this is the formation of hydrogen, or production of hydrogen by using a photocatalyst, in which this system, photocatalyst and co-catalyst, is directly kept in contact with the water. Okay, there is a possibility of a recombination of the electron and hole formed. So that recombination is one of the drawback of photocatalyst. Therefore, it is not giving the efficiency is comparatively less, but it still produces hydrogen. Now the light energy excited an electron in the catalyst. This is the working of photocatalytic water splitting. The reaction involved, which produces a hole, will react with the neighboring water molecule H2O, which is in liquid form. It takes the sunlight energy H nu plus the H plus, gives H plus proton plus oxygen. Now the H plus ion, it combined to produce hydrogen at the surface of the co-catalyst. that is 2H plus 2 electron gives H2 gas. Now the produced hydrogen, it can be used as a fuel in hydrogen fuel cell. Now the second one, that is photo-electrocatalytic water splitting. It produces little more efficiency compared to photocatalytic water splitting. In photo-electrocatalytic water splitting, it is an artificial photosynthesis approach for hydrogen fuel production, which involves the photo-generated carriers on the surface and reactants absorbed on the surface or in the electrolyte. Carriers means the electrons as well as the holes which are generated. The reaction takes place at the electrode or electrolyte interface. So we'll take the example. I'm taking a vessel. A vessel is constructed to which electrolyte is added. Electrolyte is water with containing ions. That is electrolyte. Now two electrodes are placed. One act as anode, other one act as cathode. To the anode side, another extra coating is done with a catalyst, which acts as a photocatalyst. Now these two electrodes are connected externally for the movement of electron, or to get the to make the electrons to flow through that one, so that the process will be electrolytic process. Now why called photoelectrocatalytic water splitting? Here photon is there, sunlight is there, and the electrons which are produced, it are used in a anode cathode concept called as electrolytic cell. Okay, therefore both concepts are in present together. Therefore we call it as photoelectrocatalytic water splitting. Now when sunlight falls on the photocatalyst, the water molecule will split it to give oxygen plus electron plus H plus. Okay, now this H plus will move towards the cathode side or towards the other electrode, and the electrons will move towards through the external circuit. It will reach us on that surface where it combines with that 2H plus. It produces a hydrogen gas. Okay, so this is the second method, that is photoelectrocatalytic water splitting to get a hydrogen gas. Okay, so the same thing is schematically represented here. When light energy excites the electron in a semiconductor material, that is the electrode, which is the coating present there, then the produced H plus will react with the neighboring water molecule, produces H plus. That H plus moves towards through the electrolyte, the other electrode, and oxygen is generated in the same compartment. Electrons will move towards through the external circuit. H plus ion formed will then bond with one other proton and combine with two electrons to form hydrogen gas. So that is the production of hydrogen gas. Again, the produced hydrogen can be used in the hydrogen oxygen fuel cell. So hydrogen oxygen fuel cell, or generally called as hydrogen fuel cell, already might have studied in detail about the construction and working. So a simple schematic representation is given. It consists of two electrode, platinum palladium electrodes, through which hydrogen gas is passed. So these hydrogens, what we say, it is produced by the photocatalytic water splitting or photoelectrocatalytic water splitting. Alkali is used as electrolyte, oxygen acts as the oxidant. The reaction takes place, produces electricity. Okay, so hydrogen fuel cell is there to produce electricity or electrical current. Now the second one, that is methanol oxygen fuel cell, its construction. Now, methanol oxygen fuel cell, it also consists of two electrodes. One act as anode, the other one act as cathode. Both these two electrodes are nickel coated with platinum and palladium catalyst. Nickel metal with the coating of platinum or palladium catalyst. Now, these are further constructed into a chamber through which CH3OH methanol is passed through that chamber containing the anode. We call it as anode chamber. Okay, so the methanol containing a little bit of acidic sulfuric acid, it is passed through anodic compartment, and the other compartment of cathode side, we call it as cathode compartment, through which oxygen is passed. Oxygen is passed through the cathodic compartment. Now, the center part, that is the electrolyte, H2SO4 sulfuric acid is act as electrolyte, and there is a coating, a membrane coating is given so that methanol cannot diffuse through the electrolyte to the cathode. Membrane is provided which prevents the diffusion of methanol into the cathode. Now it's working. In methanol oxygen fuel cell, the methanol acts as the fuel, which is taken in the anodic compartment, and oxygen act as the oxidant, which is taken in the cathodic compartment. Now the reaction at the anode surface, on the anode surface, methanol will combine with the water molecule to give carbon dioxide, H plus and electrons. Now this H plus will travel through the electrolyte medium, already it is sulfuric acid. H plus will diffuse through the cathode media. Electrons will travel through the external circuit. So it should have an external circuit connected with the anode and cathode. Electron will move towards the external circuit. Then at the cathode surface, the oxygen which is passed through the cathode compartment combines with H plus and 6 electron to give 3 moles of water. Therefore, the net cell reaction we can write as CH3OH, methanol plus 3/2 oxygen gives the carbon dioxide plus water molecule. Okay, so reaction at anode, reaction at cathode, and net cell reaction. If you see, you can say methanol and H2, only one H2 on the reactant side, 3 H2 on the product side. Therefore, that get cancelled and we'll get 2 H2O. Then on the other side, here 6H plus 6 electron, they get cancelled. And finally, we'll get CH3OH plus 3/2 to give CO2 plus 2 H2O. Now its applications of methanol oxygen fuel cell. Methanol oxygen fuel can produce limited power, but it can still store high energy content in very small space. They can produce a small amount of power over long period of time. They will not give higher energy. A burst of energy is not there. A thrust of energy is not there. Small amount of energy will be given, but it will give the same energy for a long time period. Therefore, it make ill-suited. It is not suitable for powering larger vehicle. Big vehicles cannot be used, but ideal for smaller vehicles and many consumer goods such as mobile phones, digital camera or laptop. It can be used, but its main application it is in military application. Are the one of the emerging applications, since they have low noise and thermal signatures are no toxic, and there are no toxic effluent. When working of the methanol oxide fuel, it will produce very less noise. There's no much noise pollution, noise is generated, and as well as there is no heat generated. Both these are important in when we consider the military application. If a noise, if an instrument gives any noise, it is easy for the military equipments to the enemy to identify the position of the person who is handling that, as well as if it produces any heat, it can be detected easily with thermal detector, and it is not producing any toxic effluent. There is no toxicity is produced. Therefore, for military application, it's used. Therefore, in military application, it is used in man-portable tactical equipments, battery chargers, autonomous power for test and training, the instrumentation used by military. Next one, that is solar energy, is introduction, photovoltaic cell construction, working and application. Introduction to solar energy. So a large magnitude of solar energy available, which makes it a highly appealing source of electricity. By 2021 itself, now we are in 2022, the date which I am recording this class video is on 3rd March 2022. Even by 2021 itself, the solar energy becomes cheaper than the fossil fuel. Now the solar power, solar power is the conversion of renewable energy from sunlight into electricity, either by the direct conversion by using photovoltaic, or indirect conversion by using concentrated solar powers, or a combination can be used. Therefore, the second point which I said, the concentrated solar power system. The concentrated solar power system, that is indirect conversion, direct electricity we are not getting, but we are making use of the sunlight energy. It is done by using focused lens, using lens or glass or anything which can reflect the sunlight, and it can be concentrated. So you can see different models are displayed here. This I took from the internet itself, this image. Okay, so just to make to understand, okay, this is not my own work. Okay, so sunlight which falls on this folded mirrors, can be concentrated to some system where that heat energy can be used. So here also we can see the reflector convert the sunlight or concentrate the sunlight, and the concentrated sunlight can be used to produce the heat energy, can be used to convert into electricity. Now, photovoltaic system or photovoltaic cell, that is a direct conversion of sunlight into electricity itself. There's no other form of energy involved. Light energy directly to, or solar energy directly converted into light energy. It uses the photovoltaic effect. So the photovoltaic effect, it is a generation of voltage and electric current in a material upon exposure to light. That is known as photovoltaic effect. Now the importance of this photovoltaic system, they provide a suitable energy system. The solar energy is unlimited. It is a renewable source of energy. No harmful emissions and pollution is present, or harmful emission and pollution is absent. Okay, so there is a mistake here. There is no harmful emission and there is no pollution. That is what I mean by. It can be used in remote areas where transmission lines are not available. Wherever your current cannot be passed, the transmitted lines we cannot carry such remote areas. We can depend upon the photovoltaic cell or the solar cell. By using a photovoltaic cell or solar cell, global warming can be avoided because some of the sunlight energy it is used. They provide a power for spacecraft and satellite. There is no other option for spacecraft and satellite. They have to depend upon mainly on solar power. The installation is very quick and the safety record is also excellent. Now, what is photovoltaic cell? They are semiconductor devices. Solar cell or photovoltaic cell, they are semiconductor device which converts solar energy into direct current electricity. So we already know what is a semiconductor. We have studied about insulator, conductor, and semiconductor. So some materials which on kept when it is kept in a sunlight or some other source of energy, they will the electrons will be jumping from the valence band to the conduction band, and conduction is possible only in the presence of other form of energy like sunlight energy or solar energy. As long as light is present, the solar cell will generate electricity, and when lights off, power generation stops. And it does not require any recharging, and they are having a very long lifetime. The photovoltaic cell is, again, it is based on photoelectric effect. That means when light falls on a semiconductor, electron jumps into the conduction band from the valence band. The valence band holes are created, and in the conduction band electrons are created. Thus we get an electron hole layer. Electrons in the conduction band and holes in the valence band are able to move. And photovoltaic cell has to do two functions, that is the production of the charge carrier, that is electrons, and holes, that is positive and negative charge carriers should be produced by absorbing light, and those produced charge carriers should not combine to each other. It has to be separated. That means a potential gradient required, diode required, or a PN junction required within the material. So a silicon photonic cell, it is composed of a very thin wafer. Wafer means sheet, which containing very thin layer of p of the silicon kept above p of the silicon. So I'm drawing that one. So p of the silicon and boron of the silicon. We know silicon is a semiconductor, but it need to be doped to make it an extrinsic semiconductor. Therefore, doping can be done by two methods: either phosphorus, which is a pentavalent impurity, or boron, which is a trivalent impurity. So when we add phosphorus, it becomes extra electrons will be produced in the silicon layer. When boron is added, boron is doped with silicon, extra holes are generated. Okay, therefore P doped silicon act as the N type, and B doped silicon, boron doped silicon act as the P type silicon layer. A PN junction or depletion layer is formed between these two layers. When they are combined to each other, we can say excess electrons are there on the N type, excess holes are there, excess positive charges are there in the B type. When they are joined together, they are kept together, it forms a depletion layer. The electrons and holes will try to compensate their charges such a way that a layer is formed, and that layer will not allow the movement of electrons in through this depletion layer. it has to be, that means it acts as a diode or PN junction diode, or it acts as a potential gradient. Now metal grids are placed above p-doped silicon. So p-doped silicon which is kept above the boron doped silicon, here the sunlight has to fall. Therefore electron grids are metal grids are kept here, and near to the boron doped silicon or a base layer that is made up of metal, a metal layer is kept there. An anti-reflective layer is also kept above the N-type silicon. It increase the intensity of light which is passing. When light falls, if a light reflects, the anti-reflective layer will increase the concentration or the amount of light in the system. Therefore, an anti-reflective layer is also kept above the feed of the silicon. Now, the metal grid and the metal sheets are connected externally for application. That means voltmeter is connected to the metal grid as well as the metallic layer. So now the circuit completed. Now it has to produce the electron and hole, and that has to come through the external circuit. For that, since it's a semiconductor, it needs sunlight energy. Okay, now this is the upper layer, the presentation of a photovoltaic solar cell. You can see the metal grids. What I mean by the metal grids are like this. They are all interconnected. Even metal bars are there in between. Even fingers, so-called fingers also. So you might have seen a photovoltaic cell, a photovoltaic panel. That a photovoltaic cell has got a metal grid upper surface. Now this also a schematic representation showing the bottom metallic layer and the top the front contact over the metal grid, then anti-reflective layer and a p-doped silicon and boron doped silicon material at the middle. Those are the material which is present at the middle, that is two layers. One is the p-doped silicon, the other one is boron doped silicon, and they are connected externally. The metal grid and metal layer are connected externally. Now working of photovoltaic cell. Now the semiconductor which is doped, it has the capacity to absorb light, and a part of the energy of the absorbed photon is given to a charge carrier, that is electrons and holes. So when sunlight falls on this system of two layers of silicon, both layers the light can travel through that. Okay, electrons will be formed, the extra electron will be excited in the N-type silicon, and the holes also will be excited. Means they become a little bit free to move, more free to move. Already electrons are there, more electrons and holes are becoming free. Now a semiconductor diode separate and collect the charge carrier and conduct the generate electricity in a specific direction. That is the second function of the photovoltaic cell. So first function to generate for charge carrier. Now the second function is to collect and separate the charge carrier. That is done by this depletion layer or the PN junction diode, which pushes the electron. The electron cannot penetrate through this because opposite side of that layer there are electron layer. Therefore, it cannot penetrate through that. It has to go to the metal grid, and the positive charge the hole or the holes also repelled. It has to go to only to the metallic layer. Now the electrons move towards metal grid and holes migrate toward the metal layer. And then these two ends are electrically connected. Current flows through the external circuit. So already we connected the metal grid and the metal layer through a voltmeter. Now this electron has to travel through this voltmeter or through the external circuit to combine with this positively charged hole. Therefore, the movement of electron is schematically represented here like that. Even the positive charge also can move through this silicon layer, and the electron will travel through the external circuit. Okay, so it goes through the voltmeter and it goes and combines with the positive charge. That means a photoelectric current is produced. Okay, so the voltmeter will show the deflection, or it shows that how much current is generated. That means totally we got the photovoltaic current or photoelectric current it is produced. Now applications of photovoltaic cell. It can be used to supply electricity for telecommunication repeater stations. It can be used to power electricity for water pumps, navigational aids. It can be used in laptop computers. It can be used as cottages and remote residences. It can be used in parks in remote regions. It can be used for supplying occasional power when there is no regular current supply is not there. That time we can use the photovoltaic cell. So that about this particular class video. Please do subscribe my YouTube channel, My Intuition. Now, regarding the hydrogen production, it is different scientists, they are doing their best to produce maximum hydrogen. Some of the thing research which is still going on, that is how to store that hydrogen in a high pressure situation, the storage tank, all those research work are still going on, and very soon we can see vehicles with hydrogen fuel cell. In place of a petrol or diesel, we only have to pour the water, and that will produce the hydrogen. Or even we can combine many things together with the photovoltaic system and the hydrogen fuel cell combined. It can be, you can see very near future, we can see the vehicles already market. It is the prototypes are available in market, produce which is the vehicle running with hydrogen fuel cell. Now regarding the photovoltaic cell or the solar cell, already solar panels we might have seen many places which produces electricity. Research is further developed, continued, and we now we have a very thin photovoltaic solar cells. Even there are flexible solar cells. Even there are spray type solar cells are also produced. Means we can coat, or we can have the upper surface of a vehicle can be coated with that flexible solar cell, which will produce electricity. Because the at present the silicon solar cell what we use, that is very brittle nature, it will break easily. But nowadays a newer version, that flexible solar cells, flexible electronics, everything is introduced. Therefore there is a tremendous research is going on. In a very future we can see the replacement of the old fuels like petrol and diesel, which are non-renewable sources of energy, will be completely replaced with non-renewable sources of energy like water or hydrogen production, even solar cell, that is sunlight energy. So all this will be there in the market very soon. Hope it should come at the earliest. And I hope that this particular class video was benefited to you. Thank you very much for watching my video, and have a nice day.